All right, so this video is going to go over Module 1 Homework 1 notes. So this video corresponds with Module 1 Homework 1 assignment in MyLab Math. These questions I took straight from there, so you should have the same type of questions, just different numbers. So starting off, solving linear equations. So it asks us to solve the equation 2y plus 4 times y minus 6 equals 7y minus 3 times y minus 10. So we're going to use order of operations. Remember, order of operations tells us to do PEMDAS. First, starting off with parentheses. So we need to get rid of our parentheses. So in order to do that, I want to distribute this 4 that's outside the parentheses and also distribute this negative 3. Don't forget that negative that's out front of the second set of parentheses. So we are going to distribute. So that means 2y is left over, plus 4 times y will give us 4y. 4 times negative 6 will give us negative 24 equals 7y. Again, distributing that negative 3, so negative 3 times y is negative 3y. Negative 3 times negative 10 will give us plus 30. So now we have a lot of stuff going on. Let's simplify this a little bit by combining like terms. We are now going to combine like terms. So for example, 2y plus 4y are like terms. So 2y's plus 4 more y's would give us 6y minus 24 equals, sure that looks like a y, equals, still combining like terms on the other side, 7y minus 3y is like terms. 7y minus 3y will give us 4y plus 30. Now we have y's on both sides and we have constants, so just numbers by themselves on both sides. So let's combine those like terms. So let's bring this 4y over here with the 6y. So if you notice, it's on the other side of our equal sign. So we have two sides of the equation and it's on the other side. So to move this to the other side of the equation, to move it to the other side of the equation, that means we have to do the opposite. We need to cancel it on the right side and bring it on the left side, or vice versa. So if this is positive 4y, in order to cancel it out, we need to do the opposite. The opposite of positive 4y is negative 4y. So let's subtract 4y from both sides. That way 4y minus 4y goes to 0 and it cancels out. So we're left over with, 6y, and if you need to draw a line, if it helps you, go for it. 6y minus 4y would give us 2y minus 24 equals 30. Again, combining like terms, bringing that negative 24 to the other side of the equation. Bring it to the other side means we need to do the opposite. So notice up here, we were combining same side of the equation. So we just combine those like terms. Now we're moving it from one side to the next. Now is whenever we want to cancel it to do the opposite. So the opposite of negative 24 is positive 24. So we're going to add 24 to both sides. That'll leave us with 2y equals 30 plus 24, which will give us 54. And last but not least, it's still kind of like combining like terms. I want to get that y by itself. I want to get that 2 over there with the 54. So that means in order to move it to the other side, we need to do the opposite. It's 2 times y. So in order to move it to the other side, we need to do the opposite. So the opposite of multiplication is division. So that means we're going to divide both sides by 2. So that way, 2y divided by 2. 2 divided by 2 will give us 1. So that way those 2's cancel each other out. And we're left over with 1y, which is just y, equals 54 divided by 2, which is 27. Here's our answer, y equals 27. Now, MyLab Math, where you do all of your homework, all of the quizzes, all of the tests, all of that good stuff, all of our assignments, kind of has a funny way of writing it. So I just copied this straight from MyLab Math. And it's like multiple choice, like A, B, C, or D. We had one answer, y equals 27. So option A says y equals some number. Option B says the solution is all real numbers. And then option C is there's no solution. So we had one answer, so we're gonna choose option A and write y equals and then just type in 27. So that's how this problem would look on MyLab Math. Let's do another one. Solve the equation 3x plus 5 equals 3x. Again, combining like terms. Oops, wrong button. Again, combining like terms. I want to move that 3x to the other side of the equation. Here's our little equation line. To the other side of the equation with the other 3x. That means to move it from one side to the next, we need to do the opposite. It's positive 3x. So to do the opposite means negative 3x. We're going to subtract 3x from both sides. That way 3x minus 3x goes to 0. It cancels out. We're just left with 5 equals 3x minus 3x again cancels. So that'll give us 0. So we're left with 5 equals 0. Our x is canceled out. 5 does not equal 0. This is a false statement. So because it's false, that means no matter what I plug in for x, it's not going to work. So no solution. There's no solution that will work, and that will be option C. All right, next example. We did option A, we did option C. I wonder what the next example is going to be. Let's try it. So solve the following equation. 5 times x minus 8 plus x equals 6 times x minus 7 plus 2. So just like we did on that first example, let's go ahead and let's make this look simpler by getting rid of those parentheses. So let's go ahead and let's distribute to get rid of the parentheses. So distributing this 5, distribute means multiply. So we're going to multiply that 5 to everything in the parentheses. And we're going to distribute or multiply the 6 to everything inside that parentheses. So just whatever's inside the parentheses. So 5 times x will give us 5x. 5 times negative 8 will give us negative 40. And then bringing down that plus x equals 6 times x will give us 6x. 6 times negative 7 is negative 42. Bringing down that plus 2. So now we got a lot going on. Let's make this look simpler. That's our whole idea, is to make it look simpler, simpler, simpler. So let's continue to combine like terms. So 5x plus 1x will leave us with 6x's. And then minus 40 equals 6x, and then negative 42 plus 2 will give us negative 40. Oops. Oops. Okay, whatever it's going to have to be. All right, so if you notice 6x minus 40 equals 6x minus 40. So notice it's the same thing on both sides. So that means no matter what you plug in for x, it's still going to be the same thing on both sides. But let's pretend like we didn't notice that, and let's keep going. Let's still combine like terms. So if you, yeah. All right, so let's bring our x's together. So moving this 6x over here with the other 6x. It's positive 6x. We need to do the opposite. We need to subtract 6x from both sides. That way 6x minus 6x goes to 0 and cancels out. Again, 6x minus 6x goes to 0 and cancels out. On the left-hand side, we're left with negative 40. Equals on the right-hand side, we're also left with negative 40. So again, negative 40 equals negative 40. This is a true statement this time. So meaning whatever you plug in for x, negative 40 is always going to equal negative 40. It's always going to be the same thing on both sides. So no matter what you plug in for x, so you can plug in any real number. So the solution is all real numbers. Any real number we can plug in for x, and it's still going to give us a true statement. So that is our option B. So I'm all about being super organized. So I created a little chart here to kind of help you see the 3 different types of solutions. So our first type was one unique solution, like our first example. So x equals 27 or whatever number. And these are our examples on the right-hand side, x equals 3, x equals 5. The next type was all real numbers, and that's whenever we got a true statement, like the one we just did. So 0 equals 0, 5 equals 5. Lastly, no solution, that's when we get a false statement like 5 equals 0 or negative 2 equals 3. So those are our 3 different types of solutions. All right, next we're gonna kind of jump out of the box and go ahead and get some stuff that you don't like over with. So we know everyone loves fractions. So we just wanted to go ahead and put that out there for you. So a little fraction review. Just going back old school basic fraction stuff so that we all start off on the same playing field. So notice a negative sign in front of a fraction can be rewritten as a negative just in the numerator, which is the top of our fraction, or a negative sign in the denominator, which is the bottom of our fraction. So for example, negative 3/4, that negative could be written out front, or it could be written up top as negative 3 divided by positive 4, or it could be written on the bottom as positive 3 divided by negative 4. Either way these are written, they're all a negative number, all a negative quantity, all a negative fraction. So we're going to use that a lot of times to help us. Sometimes it's easier when the negative's out front, sometimes it's easier when it's on the top, sometimes it's easier when it's on the bottom. So keep that in mind, we're going to use that quite a bit. Next, multiplying fractions. How do we multiply fractions? We multiply straight across. We multiply straight across. So for example, 3/5 times 1/2, multiplying straight across, 3 times 1 is 3. All over 5 times 2 is 10. Remember, if it's a fraction, you always have to try to simplify it. So there's nothing that 3 and 10 have in common to simplify. So that's our final answer. So that's multiplying. Dividing. For dividing, what we're going to do, a couple different things. I say stay, change, flip. Some people say multiply by reciprocal. Some people say keep it, change it, flip it. Some people say KFC, because I think they want me to be hungry. But no matter what, it's all the same thing. So for example, if we have 3/5 divided by 1/2, that 3/5 is going to stay the same. Divided by, that division symbol is going to change to multiplication. And then we are going to flip that last fraction. So instead of 1/2, it is now going to become 2/1. So now it is multiplying. So now we can multiply straight across. So 3 times 2 is 6. All over 5 times 1 is 5. So a couple different things here. We want to always simplify, but there's nothing that 6 and 5 have in common. So we can just leave it like this. Everyone wants to change this into a mixed number, meaning 1 and 1/5. 1 and 1/5 doesn't really help us out algebraically, because if I want to multiply top times top, bottom times bottom, so we don't do this. We just leave, and that's more work. We have enough work on our hands. So we don't want to do any more work. We want to leave it as an improper fraction of 6/5. All right, adding. So 3/5 plus 1/2. Looking at this, I have fifths and I have halves. They're not the same thing, so I do not have like terms. So we have to make them be like terms. So that means we have to get a common denominator. Remember, the denominator is the bottom of our fraction, so get a common bottom of our fraction to make them like terms. So to make like terms. All right, so if we have 3/5 and 1/2, I want to make the denominators the same. So what is the least, what is the smallest common denominator? What's the smallest number that I can make both 5 and 2 into? So they both can be made into 10. So meaning, what, starting off with this 3/5, if I multiply by 2, that'll make it into 10. What you do to the bottom, you have to also do to the top. So 2 times 3 will give us 6. All over 2 times 5 will give us 10. So 3/5 is the same thing as 6/10. We just wrote it differently so that way we can combine like terms. Plus 1/2. Again, we want to make that denominator 10. So I multiply by 5. 2 times 5 will give us 10. What I did to the bottom, I have to also do to the top. So that means I have to multiply the top also by 5. Oops. So plus, oh, wrong color. So 1 times 5 is 5. All over 2 times 5 is 10. So now I have 6/10 plus 5/10. So now they're both tenths. So now they're like terms. So if I have 6 of these things plus 5 more of these things, I'd be left with 11 of these things, or 11/10. So 6/10 plus 5/10 is 11/10. Again, trying to simplify, 11 over 10. 11 and 10 have nothing in common. We do not need a mixed number, so we can leave it just like that. So we did multiplying, we did dividing, we did adding. Last but not least, subtracting. Subtracting is the same thing. We have to get a common denominator to combine like terms. If we have 3/5 minus 1/2, notice same exact example that we did up here. So that way we know it's tenths, we know it's going to be 6/10, but this time it's minus 1/2. I'm sorry, minus 5/10. We made them like terms. All right, so 6/10 minus 5/10. Now they're like terms. So 6/10 minus 5/10 will give us 1/10 left over. That's in simplest form. We're done. So last thing kind of for our little review here, bind up our review, is LCD. We talked about LCD up here where we had to have our least common denominator to make them like terms. And in our example up here, it was 10. Let's talk about that more, because we want to make sure we really understand it so that we can apply it to something that's a little bit more our speed. So LCD stands for least common denominator. So it's the smallest number I can make both numbers into. So for example, find the LCD for 8 and 36. Some of us can just look at it and just know the answer. Some of us have to do a little bit of work. I want to do a little bit of work so we can kind of see what's going on in an easy example, so that way we can apply it to something that's a little bit harder. So let's find all of the options for 8. What are all of the multiples for 8? So let's say 8 times 1 will give us 8. If we did times 2 will give us 16. If we did times 3, it'll give us 24. If we did 8 times 4, that'll give us 32. If we did 8 times 5, that will give us 40. If we did 8 times 6, that'll give us 48. If we did 8 times 7, that'll give us 56. If we did 8 times 8, that'll give us 64. If we did 8 times 9, that'll give us 72. If we did 8 times 10, that would give us 80, so on and so forth, blah, blah, blah. So let's start there. So same thing, these are different options that we can turn 8 into. Same thing with 36. 36 times 1 is 36. 36 times 2 is 72. Let me stop right there. Reason why I'm stopping is, boom, I see a number they have in common. So they both have 72 in common. This is the smallest number they have in common, so I don't need to go any further for one. So we can say blah, blah, blah. But, so that means our LCD is going to be 72. 72 is the smallest number in common. So meaning I can multiply the top and the bottom by 9 if it was at 8, or I guess we'll do it in the next problem. So let's use this. Let's add 1/8 plus 3/36. So as of right now, they're not like terms. 8 and 36 are not the same thing. But looking at this and looking at the previous example we just did, we need to find an LCD. So between 8 and 36, we know the LCD is going to be 72. That's the smallest number we can make both of them into. So looking at 1/8, I need to make 8 into 72. So we know 8 times 9 is 72. So I can multiply the top and the bottom by 9. That means 9 times 1 is 9. All over 9 times 8 is 72. So that's done. Plus 3/36, making that into 72. We know that 36 times 2 will give us 72. So that means I need to multiply the top and the bottom by 2. So 3 times 2 is 6. All over 36 times 2 will give us 72. So now I have 9 70-seconds plus plus 6 70-seconds. So now they're like terms, they're both over 72. Combining like terms, 9 of these things plus 6 more of these things will give us 15 of these things, 15 over 72. Now trying to simplify, looking at 15 and 72, I notice they both have a 3 in common. So I can factor or divide out that 3 from the top and the bottom. 15 divided by 3 will leave us with 5 up top. 72 divided by 3 will leave us with 24 on the bottom. 5 and 24 have nothing left in common, so that's our final answer. All right, so now that our review is done, let's kind of bring it up a notch and bring it to something that's a little bit more our speed. So solving negative x plus 2 over 6 plus x equals 3 over 5. So it's putting together the solving equations that we did at the beginning with this fraction review. So first things first, no one likes fractions, I know. So let's go ahead and let's get rid of the fractions. Just like we did earlier, in order to get rid of something, we did the opposite. So fractions mean divide. So in order to get rid of the division, we need to do the opposite. We need to multiply. So we are going to multiply everything by the LCD to get rid of our fractions. So looking at this equation, my denominators are 6 and 5. So I need to find an LCD. So what's the smallest number I can make both 6 and 5 into? And that will give us an LCD of 30. So I want to take this LCD of 30 and multiply it to every single thing on both sides of the equation. All right, so here's another thing. This negative that's out front, I don't want to lose it because I know I'm eventually trying to get rid of the bottom. So I want to go ahead and put it at the top of my fraction. So that way I don't lose it along the way. So negative x plus 2 all over 6. Notice I put that x plus 2 in parentheses. This is separated by the fraction bar. So when I'm going to get rid of that fraction bar, I need to make sure it stays separate. This negative is applying to the x and it's applying to the 2. So make sure you put that in parentheses. Plus x equals 3 over 5. So we are going to distribute this 30 to every single term on both sides of the equation. If it helps you, it helps me, I don't know, but write 30 over 1. So that way whenever we're multiplying, we multiply straight across. We're going to multiply fractions straight across. So, for example, 30 times negative x plus 2. So 30 times that negative will be negative 30. And I'm going to leave it at x plus 2. We'll come back in another step, and we'll come back and distribute it in a minute. All over 1 times 6, which is 6, plus 30 times x, which is 30x, equals 30 times 3 up top will give us 90, all over 1 times 5, which is 5. So basically that 30 went to the top of every single fraction. The bottom stayed the same. So now whenever we simplify, our fraction should go away. So negative 30 divided by 6 should give us negative 5. Again, we are going to eventually distribute into the x plus 2. So right now, just leave it as x plus 2. We'll distribute it in a minute. We're just trying to make things look nicer before we make it look worse. Plus 30x equals 90 divided by 5, which is 18. Now this is an equation that I am able to solve. So it's a lot better. We got rid of the fractions. We can now solve this. So now let's go ahead and let's distribute this negative 5. Oops. Negative 5 times x would be negative 5x. Negative 5 times positive 2 would give us negative 10. Plus 30x equals 18. Let's combine like terms. So negative 5x plus 30x will leave us with 25x minus 10 equals 18. Combining like terms, I want to bring that negative 10 on the other side. So if it's on the other side, I want to do the opposite. So add 10 to both sides. So that way negative 10 plus 10 goes to 0. It cancels out. So we're left with 25x equals 18 plus 10, which is 28. And last but not least, it's 25 times x. So to get x by itself, I'm going to get rid of that 25. So I'm going to do the opposite. I want to divide both sides by 25. That way 25 divided by 25 is 1x. So they cancel each other out. We're just left with x equals 28 over 25. 28 and 25 do not have anything in common, so that cannot be simplified. So that's our final answer. Again, don't put a mixed number. All right, let's try another one. Or if you want, this would be a great time to pause it and you can try one by yourself. So solving 1/5 times a plus 2 equals 1/6 times 2 minus a. So again, I want to get rid of the fractions first. Don't worry about distributing because I'll distribute it. I want it to look nicer. And I want to get rid of the fractions and then I'll worry about distributing in a second. So first finding an LCD. So looking at my denominators, I have 15 and I have 6. So what's the smallest number I can make both 15 and 6 into? I'm thinking 30. So we're going to multiply everything on both sides of the equation by that LCD of 30. So 115 times a plus 2 equals 1/6 times 2 minus a. So distributing it to the 1/15th. That 1/15th is eventually going to go into the a plus 2. So again, we're just going to distribute it to the 1/15th, and then eventually we'll distribute it into the a plus 2 once it looks a little bit nicer. Same thing on the other side. Let's do 30 times 1/6. Once that looks nicer, then we will distribute it into the 2 minus a. If it helps you to write 30 over 1, go for it. So that way, whenever you distribute that 30, you're going to multiply top times top, bottom times bottom. So 30 times 1 is 30. All over 1 times 15 is 15. Times a plus 2, eventually we'll distribute, equals 30 times 1 is 30. All over 1 times 6 is 6. Times 2 minus a, again, eventually we'll distribute. So now let's simplify. So we distributed. Now we are going to distribute LCD. Now we are going to simplify. So 30 divided by 15 will give us 2 times a plus 2 equals 30 divided by 6 will give us 5 times 2 minus a. Now, this is a lot easier for us to distribute a 2 and a 5 than it would be to distribute those crazy fractions. So now we can distribute and now we can solve this thing. So 2 times A will give us 2A. 2 times 2 will give us plus 4 equals 5 times 2 will give us 10. 5 times negative A will give us negative 5A. We're getting closer. Now we can combine like terms. Let's bring our A's together. So I want to bring this negative 5A to the other side of the equation. So that means I need to do the opposite. The opposite of negative 5A is positive 5A. So we can add 5A to both sides. That means we're left with 2A plus 5A is 7A. That doesn't look like a 7. Plus 4 equals 10. Negative 5A plus 5A goes to 0 and it cancels out. Same thing, I want to move that positive 4 to the other side of the equation with the 10. So in order to move it to the other side, I want to do the opposite. So it's positive 4. So the opposite is subtracting 4. That way 4 minus 4 goes to 0 and it cancels out. We're left over here, let's come over here, with 7A, the 4's cancel, equals 10 minus 4, which is 6. Last but not least, it's 7 times A. I'll move that 7 to the other side of the equation. So I need to do the opposite. The opposite of multiplication is division. So I'm going to divide both sides by 7 to cancel out those 7s. So we're left with A equals 6 over 7. There's nothing that 6 and 7 have in common to simplify. So that will be our final answer. All right, so we did fractions, we did solving equations. Let's go ahead and just knock out all the bad stuff in once and let's do word problems. It always makes me laugh when I look at this and it's like, really, we're just gonna go ahead and knock out everything at once. So every word problem is completely different, but let's go over just a couple examples that came straight from your MyLab Math homework assignment. So same problem, just different numbers. First example, the sum of 3 consecutive odd integers is 213. Find the integers. All right, let's really think about what this means. So the sum means we're going to add up 3 consecutive. Consecutive means back to back. Odd integers means whole numbers. Is means equals 213. So if I'm going to add up 3 back-to-back whole numbers, they have to equal 213. So I don't know what it is. So some number plus some number plus some number is going to have to equal 213. Now here's the tricky part. How am I going to make them consecutive back-to-back odd numbers? So let's kind of think about this. Let's do a little example down here. What are, just in general, 3 consecutive odd numbers? Let's do some easy ones. So like 1, 3, 5. 1, 3, and 5 are like just some easy random consecutive odd numbers. So let's try to come up with a formula to get from 1 to 3 to 5. So let's say if 1's x, how would I get to 3? Well, that's going to be x plus 2. 1 plus 2 will give us 3. If I had 1, how would I get to 5? 1 plus 4 is 5, so x plus 4. So now we have some equations we can plug in. So we have x for the first one, x plus 2 for the second one, and then x plus 4 for the last one. That will give us 3 consecutive odd integers. Be careful. Some people says 3 consecutive odd integers. Some people says 3 consecutive even integers. Some people say just 3 consecutive integers in general. So your little formula down here that we did will be based on what your problem's telling you. So now we have an equation. We can solve this equation. I just want to rewrite it so it looks a little bit better. So we have x plus 2 plus x plus 4 equals 213. Let's combine some like terms here. So 1x plus 1x plus 1x. X plus x will give us 3x. And then combining our numbers, 2 plus 4 will give us plus 6 equals 213. So now solving for x, I want to bring that 6 to the other side. So I need to do the opposite. It's positive 6. So the opposite means we need to subtract 6 on both sides. That way 6 minus 6 goes to 0 and cancels out. We're left with 3x equals 213 minus 6, which is 207. And then last but not least, getting rid of that 3. It's 3 times x, so we need to do the opposite. We need to divide both sides by 3. That way those 3's will cancel. Oops. We're left with x equals 207 divided by 3, which is 69. So we got x equals 69. But remember, the question doesn't say what is x equals. The question wants 3 consecutive odd integers. So if 69 is our first one, going back here, if 69 is our x, what's our next one? 69 plus 2, which will give us 71. Then what's our third one? 69 plus 4, which will give us our last one, which is 73. So our 3 consecutive odd numbers are 69, 71, 73. Now just looking at this, let's make sure this makes sense. 69, 71, 73 are 3 back-to-back consecutive odd numbers. And if I add them all up, they do equal 213. So we did that right. All right, let's look at another example. So if we spend $100 and the tax rate is 8%, write down how much money we're gonna pay in taxes. All right, so how much money we're gonna pay in taxes means I'm gonna pay 8% of what I paid. So 8% of that $100. So in math, I can't plug that percentage into my calculator, but if I move my decimal 2 times to the left, that will give me 0. Plugging in a 0 to the whole, 0.08. In math, the word of means multiply, so times $100. So in my calculator, 0.08 times 100 will give me 8. So that means if I have 8% tax rate and I'm spending $100, that means I'm gonna have to pay $8 in taxes. So next example, so kind of bouncing off this previous one. So if we spend now X dollars, so before it was $100, now we're spending X dollars and the tax rate is 8%, how much money will we pay in taxes? So same concept, we're gonna spend now we're gonna pay 8%. This time it's X, we don't know how much we're paying. So turning that percentage into a decimal, moving our decimal 2 times, the decimal's at the end. 2 times to the left, here's our new decimal, filling in the gap with a 0. 0.08 of means multiply, so times X dollars. So 0.08 times X, which is just 0.08X. We don't know what X is, so we cannot go any further. That's our final answer. So now using these, let's add to it one more time. So it says, for example, a new TV was recently purchased for $475.20, $475.20, including tax. So if the tax rate is 8%, find the price of the TV before tax. So like working backwards now, finding the price before tax. So we know that it's gonna be our original, or our price before tax, let's call it that. Our price before tax plus whatever tax we pay is gonna equal our total. So price before tax, that's what we don't know. Let's call it X because that's what we're looking for. Plus our tax. We don't know what our tax is, but we know it's gonna be 8% of what we paid. So 8% of the price before tax, so 8% of X is gonna equal our total. They told us the total was $475.20. $475.20. So on the previous example, we found what is 8% of X. We did that over there and we said it was 0.08X. So that means x plus 0.08x equals 475.20. We now have an equation we can solve. We have x, or if you want, just put 1x. 1x plus 0.08x's, combining like terms, will give us 1.08x equals 475.20. So now getting x by itself, we're going to do the opposite. It's 1.08 times x. So to get x by itself, we need to do the opposite. We're going to divide both sides by 1.08. That way those cancel out. And we're left with x equals 475.20 divided by 1.08, which will give us 440. We're talking about $440, so make sure you label it as money as dollar signs. So our price before tax, our price of the TV was $440. Including that 8% tax would give us our total of $475.20. All right, so last example for this notes section. Solve the equation T equals C times 7 plus AB for A. Be careful. Notice how our letters here are all uppercase, so make sure that you leave, whenever you type in your answer into MyLab Math, into your homework and your quizzes and your tests, make sure you leave it uppercase, because to them, lowercase t is a different answer than uppercase t. So be careful with that. So we're going to solve it exactly like we would do normally. So I'm just going to rewrite it. So T equals C times 7 plus AB. Couple different options here. Usually, remember we're trying to solve for A. Usually what people do first is they see parentheses and they want to distribute. So that's fine. Let's go for it. So T equals C times 7, which we can write as 7C, plus C times AB, so A, B, C. Remember, we are trying to solve for A. So I want to move this 7C to the other side to slowly get A by itself. It's positive 7C, so just like we did before, same thing. We're going to subtract 7C from both sides. Ow. That way 7C minus 7C cancels out and goes to 0. All right, so we're left on the left-hand side with T minus 7C. Those are not like terms. I cannot combine them. So we're just going to leave it as T minus 7C equals A, B, C. Remember, we're trying to get A by itself. So I want to move that B and C to the other side. It's A times B times C. So in order to move it to the other side, we want to do the opposite. So the opposite of being multiplied is divide. Oops. So we want to get A by itself, so I want to move that B and C over. So we're going to divide by B and C. We divided the right whole side by BC, so that means we're going to divide the whole left side. So make sure your line's going to include everything, B and C. That way our B cancels, our C cancels, A is left by itself. So A equals T minus 7C all over BC. And that's our final answer. Notice our C's can't cancel because they are different families. They have to cancel the whole thing. But because this T is attached to it, doesn't have a C, I can't cancel anything out. So that's our final answer. So that is Module 1, Homework 1 notes. If you have any questions, as always, please email me or our peer tutor to help you out. Thank you.